Yes, I published creative computing for umpty-ump years, but the topic of this talk, as agreed to beforehand, was the history of computer games, the first 50 years. So we're going to be looking at computer games from roughly 1940 to 1990. We may not quite get up to 90, but I'll do my best. Now, computers weren't really invented to play games. Somebody someplace along the line thought it would be kind of a cool thing to do. But computers, the early ones, when you think of it, they were expensive and built for specific purposes. Your first computer that a lot of people think of is the one that was built at Bletchley Park, the BOM or Bombay, designed by Alan Turing, and it had one purpose in mind, or to do, and that was to read messages that the Germans were sending on the Enigma code, or in the Enigma code, produced on a machine that had three revolving drums and plug-in boards and zillions and zillions of combinations of messages. We could go into that. In fact, I have an interesting little book here, Bletchley Park Brain Teasers, and that kind of brings me to the opening of this thing, and that is Alan Turing. So what did Alan Turing do after Bletchley Park? After the whole code-breaking thing came to an end? Well, he came over here, he came over to America, he consulted with the our intelligence service at the time, OSS, but he also kind of went into other directions, and one of them was proposing a game. And let me read you. He had this in the 1950, June 1950 issue of Computing Machinery and Intelligence. That was the article name, and it appeared in Mind magazine, M-I-N-D. And what he proposed in that article was what has become a fairly famous game, the imitation game. And he never programmed it himself, interestingly enough. He proposed that it be done, and the idea was that let me read what he says. In the game, the user would converse with a computer using real phrases and sentences. And the way Turing described it is he had a room with two doors. Behind one door was a human, behind the other door was a computer. There was a person in the room with a telephone that could communicate to either of those two rooms. And when he could no longer tell which room had the computer and which had the human, then the game was, quote, solved. Basically, he said, artificial intelligence has then been achieved. Turing, as I say, never programmed that, and we had to wait actually for 13 years for Joseph Weizenbaum at MIT to devise a game which he later called ELIZA. Now, ELIZA was kind of cheating at the game because you would converse with either the computer or the human, but let's say with the computer, and you'd use real phrases. How would the computer reply? With a question. With a question. And it would finally, after asking enough questions, it would get to know. You could be talking about your brother, and the computer would reply, where does your brother live? How old is your brother? What does your brother do? And then finally, the computer starts feeding some of that back to you, and you say, oh boy, this computer's pretty smart. And that's how ELIZA worked. In fact, I programmed a version of it, a very simple version, at Digital Equipment in the late 60s. It was an interesting exercise, let's say. By the way, I should mention one other thing about Alan Turing. Alan Turing and I share one let's say, characteristic. I'm not sure that characteristic is quite the word, but we are both absolutely, totally hopeless at crossword puzzles. My wife, on the other hand, is an absolute expert at crossword puzzles. Now, British crossword puzzles, I don't know how many of you know about British crossword puzzles, quite different than American crossword puzzles. British crossword puzzles, basically, here I had a little description of it. Someone was writing about them and said that cryptic crosswords were, during the war years, were somewhat similar to those enjoyed now, but there's a suggestion that today's generation might struggle with those vintage cryptic puzzles. The linguistic double backing and somersaulting is much the same, but puzzles then would have been required to have a depth, or puzzlers would have a depth of general, cultural, classical, and biblical knowledge that might not necessarily be prevalent today. Puzzles were diverse. They used anagrams, riddles, cryptic definitions, and homophones, double definitions, and wordplay in a much looser format. So anyway, British crossword puzzles are different than American ones. And where do you think the first people that were recruited for Bletchley Park for the code-breaking team, how were they selected? Mathematicians, scientists, what were they?
For the newspaper.
There were, the Sunday Telegraph in Britain ran a contest, and their puzzles were notoriously difficult. Took hours and hours to solve the puzzle. They ran a contest and they said, anyone that could solve this puzzle in 12 minutes or less will get £100, which back in 1942 was a lot of money. And then they had some pre-qualification, and then they had several hundred people come into the Daily Telegraph offices on this day and gave them the puzzle. 5 people solved the puzzle. They then got a visit from someone in MI6 saying, would you like to talk to some people here? We have some recruiters. And anyway, those people were the first code breakers at Bletchley Park. From then to now, well, not now, but the entire time that Bletchley Park was in operation, crossword puzzles were just an absolute mainstay. Now, here's an interesting little piece of trivia. The two most difficult crossword puzzles in England at the time, one was published by the Telegraph and one was the Times. The budget for Bletchley Park was gigantic. However, they were restricted to getting only one of each newspaper every day. So all the code breakers, you had about 60 of them, what they had to do is they had to pick up the Times and by hand copy out the crossword puzzle so that the next person could also, and so all 60 of them were doing it, but they couldn't possibly afford more than one newspaper. Strange. Okay, let's, should have showed you that. That's Alan Turing's computer, the Bombay, a single-purpose computer, not programmable. The programmable computer at Bletchley Park was the Colossus, developed by Tommy Flowers, and those big wheels that you see are holding paper tape, and they have a certain play to them so that the paper tape doesn't get ripped or the little holes in it don't elongate. And that is still, well, that's not at Bletchley Park anymore, obviously, but that was the method that they used to make sure that they could read the tape. We could talk about the invention of Colossus later if you want, but moving along, this is a photo of, I'm sorry, I've got notes here. This, again, kind of a cloak of secrecy. There was games being played at military installations. Ooh, you're not supposed to play games at military installations. But at the RAND Air Defense Lab in Santa Monica in 1952, this fellow, Bob Chapman, developed a number of formula games. And things like NIM and tic-tac-toe, very simple, but they were, in a sense, the first games outside of the imitation games suggested by Alan Turing. Trivial, simple games, but those were among the first ones. Then there was one that was developed right here, locally at Bell Labs by Moore and Shannon called Hex. The game, some of you probably know it as Hexapawn, but it's a game with no actual solution, but it's kind of an interesting game. Then we have, that's RAND Corporation, another shot at RAND. Then we have the first checkers program. This was developed by a fellow named Arthur Samuel, again, about a year later, 1953, on an IBM 701 computer. He was up at IBM headquarters. And later that year, in 53, there was a book published called The Complete Strategist by J.D. Williams, and he was out at RAND Corporation. So you see the overlap with the military and games in the early days. The Complete Strategist, I have a copy of it. It was the very first primer, in a sense, on game theory and computer games of any kind. Then after the IBM 700 series computers came out, then people started to branch out a little bit. The first sort of non-checkers, NIM, that type of game programmed was, again, a somewhat simple one, but blackjack. Programmed in 1954 for the IBM 701. Where was, I'm jumping ahead there. Where was it programmed? Los Alamos, Atomic Energy Labs. Again, we're still in the military here. But then, okay, this was a display on a, I don't know what kind of computer it was, but it was at the University of Michigan, and it was a simulation of pool. And the balls could, as you see on the screen, is where it would be the brake, and hit the brake, and the balls bounce around this pool table and enter the thing. So that was one of the very, very first, actually probably the first graphics game. Now, again, though, we're back to the military. The military was setting the pace on simulation games for many years. 1955, there was one called Hutspiel. It was a theater level war game produced or programmed at the Research Analysis Corporation down at McLean, Virginia. Again, this military overlap of games is so interesting. Now, what happened with, okay, that's Hutspiel, that's at Rand Corporation. Now along come these two guys, three guys, Newell, Shaw, and Simon at Carnegie Mellon. And what did they program? Chess. The first chess game. And the others were doing it, but they stayed at it for 20 years. Do you notice anything about that chessboard? The size of it? You see the size?
6 by 6.
It's 6 by 6. This is chess? But it played according to chess rules, but there were certain players or pieces that were absent, and others, so it was a very simplified chess game, and it was programmed on actually by a couple of other guys that aren't usually given any credit for this, Kaiser, Stein, Ullum, and Walden, on a Maniac 1 at, guess where? Los Alamos. Again. And this is that game. This is the 6 by 6 game. It was played to examine all possible moves 2 levels deep. 2 levels deep. And at the rate of examination of 12 moves per minute. Okay, compare that to your little pocket chess games today. And, they're going at, 1,000 times, 1,000,000 times that speed. But that's where it was. It played similar, again, we're talking about a 6 by 6 board, played similar to a young player who had maybe played 15 to 20 games. That's the level of learning in this chess game. Now, let's jump ahead, and we're going to jump behind. Oh, that's the computer again that was at Los Alamos. And I'm jumping way ahead, but we're going to go back. But that is the challenge, Gary Kasparov and the ACM challenge, where IBM's Deep Thought, that was the 1990 one that came close, but not quite all the way. And then, what was the name of the one that defeated him? Yeah. So anyway, finally, chess, the world champion is a computer. And in fact, it's kind of discouraging because now there's kind of a decline in interest in computer chess because it is the world champion. You know you can't beat it. And so people are just saying, well, okay, let's move on to something else, like Grand Theft Auto or something, But anyway, there's very little interest in computer chess these days. Now, next one. This is an interesting one. Again, back to the military, back to atomic energy, Brookhaven National Labs. That is an oscilloscope, enlargement of an oscilloscope. And this is a game that I actually saw. This is probably the first computer game that I saw. It was developed by a guy named Willie Higginbotham at Brookhaven National Labs. I went there on a Boy Scout field trip. Well, you know what? You walk into a laboratory like that, there's nothing in the open. there's not, I mean, everything is behind like walls, and it's not very interesting, actually. Go to Brookhaven Labs. So Willie thought, well, I want to make this a little bit more interesting, so he set up an oscilloscope, and then he said I had this game, and it had 2 controllers, and they were about the size of a box of cards with a little button on it, and you just basically were, tennis ball was going back and forth over this net in the middle. It was significant in the fact that this was the first game where the player could actually control what was happening on the screen. In the earlier game, that I showed you on pool at the University of Michigan, it was the computer that was doing all the control. But this one, the player could actually move something, could move a paddle on the screen. Of course, this is the forerunner of Pong, much later. And the object of the game was, like Pong, to maintain a volley for as long as possible with 1 or 2 players, one on each side. So let's show you that is the oscilloscope that was used. These are little controllers boxes here. We'll rheostat on each one to move your paddle around. That was, well, let me go back. Okay. Yeah. Okay. We'll, before we go into that one, I want to talk to you, let's see if I have a photo of it. Okay. Let's go back. Well, sorry about this. So, 1969, big year. Big year for me. I changed jobs and went to Digital Equipment Corporation. Big year for digital, because digital, for the most part, in the 60s had been producing these little things called flip chip modules. People were putting them together, and you could actually build a computer out of flip chip modules. However, digital then decided, well, we can build computers, and they started building these little mini computers, and the mini computers kind of weren't mini like we think of them today. It wasn't a PDP-8, 19 inches wide. They were pretty big mini computers. This was one of them. Let me show you then what some people at MIT did with theirs. They said, and there's 3 guys. Actually, well, I'll come back to this. But there were 3 guys, Slug Russell, Shag Garretts, and Alan Kotek, and they developed this game called Spacewar. That's the screen of Spacewar. What? Not very exciting. Well, if you look at it, though, this is a time sequence photograph of the screen. What you're trying to do, how many of you have played Spacewar or are familiar with it? Okay, so most of you know, you're trying to prevent your little spaceship from spinning into the sun that has an attraction at the center, and trying to launch missiles at the other guy without the missiles also getting attracted in the sun or flying off to nowhere. And that's basically the game. But I'll tell you what, Spacewar just took the world by storm. It was one of the first graphics games produced outside of the military environment. It was produced in an educational environment. It was shared. Anybody, well, I shouldn't say anybody, any school, anybody that had a PDP-1 could get a copy of Spacewar. And it really took the world by storm. Now, let me go back to that one. That's a Bendix Bendix G15 computer. Why I know about that is that large-scale simulation games were coming into play at this time. And Carnegie Mellon, again, a real center of a lot of computer development. You had Herb Simon and Alan Newell and, a good team of people. But they had developed a game called the management game. And this was for graduate people taking an MBA. And they had simulated 3 companies in the detergent industry that were competing against each other. Call it Procter & Gamble and Lever and Purex or somebody. And they were competing on all different levels, and it was quite an interesting game. And they had programmed it in a language called Gate. The reason and that was on this Bendix computer, the reason it was programmed in that is that was a language that supported individual terminals. So it wasn't exactly time sharing, but it was darn close. And so the terminals were like that typewriter, but there could be several of them. And as they say, not quite time sharing, but close. The reason I got involved is that I entered the MBA program at Carnegie Mellon, and they had just purchased a new computer, an IBM 709, and they wanted to transfer the management game on the Bendix computer in Gate over to this IBM computer in Fortran. Guess who the guy was that knew both languages? And so that was my graduate fellowship. I didn't get to play the game, unfortunately, because by the time I translated, I knew all the algorithms, and I could have won it pretty easily. Well, not easily, but could have come out on top. So they didn't let me play it, but I had the privilege of translating it. Okay, now again, bouncing to another school in Pittsburgh, the University of Pittsburgh. And there was a guy who actually started out at Yale by the name of Omar Khayyam Moore. Can you imagine going through life with that name? Omar Khayyam Moore. He built a device called a talking typewriter for teaching reading to very young children. The device was actually built by Edison Electric. This is it. And it had a computer-controlled video display. Okay, the video was a little bit marginal because it used a slide projector to get the graphics, but nevertheless. And it used an audio recorder, and basically what would happen initially when the child pressed a key, the teacher would say what the letter was, but eventually they developed it that the way it was designed was that the computer was supposed to speak back what the letter was. And then the computer was supposed to ask for the child to type a word like cat, and then child had to type C-A-T, and the computer would repeat back cat. So it was designed to repeat back single letters, words, eventually phrases. It never went anywhere, but it was kind of an interesting development in the whole gaming world. Then we have a guy, again, another friend of mine from just down the road here in Homedale, named Michael Noel at Bell Labs. And he was the one that produced some of the first computer art. Well, I got a Bunker Ramo thing in there, sorry. We'll skip that. Okay, there's Mike, and he's producing some computer art. And this is, again, very early, but you can see he's got a little thing here, the controller, that will actually then draw lines on the screen. Ooh, this is a big breakthrough. I mean, we take this stuff so much for granted today, but this was the first time that you had a controller that would draw the lines on the screen. And then he programmed the computer to produce what he called computer art. I'll show you one of his compositions. But, okay. Now, there's another one, which actually is a little more useful. Trying to get my notes in order here. Sorry. I think we will, yeah, all right. That year of 1964, that's where we are at the moment, had another, okay, so Michael Knoll is doing graphics on the screen. The other big and probably much more important development in '64 was John Kemeny and Kurtz, who developed what? BASIC language, real-time sharing on a General Electric computer. Dartmouth College, BASIC took the world by absolute storm. All of a sudden, everybody had access to a computer. Simulation games, all kinds of games started to make their appearance. And people started to combine graphics and games, and companies started to spring up, and all of a sudden this guy, Ralph Baer of Sanders Associates, 1967, designed this little game, which eventually became Magnavox Odyssey. That's Ralph Baer, and then there was a rocket car simulation, and oh gosh, well, a flight simulation at Evans and Sutherland, lunar lander, a deck, and just all kinds of, the BASIC and the access to computers just was a staggering breakthrough. Then there was the Odyssey game, tennis game. Anybody recognize that? Game of Life, John Conway. Martin Gardner wrote it up in Scientific American. Very easily programmed, but a very low-level graphics game that you could program even on terminals that didn't have graphics characters. You could just have each of these could be a letter, could be the letter A or something like that. So again, a bit of a breakthrough. And then we had, well, let's go, before going into that, National Science Foundation got active. They said, oh, these simulations, they're good, and that they encouraged all kinds of projects. There was one, the Huntington Computer Project on Huntington, Long Island, and they produced a series of booklets, actually digital equipment where I was working at the time. We reprinted these booklets, and these are simulation games. This is a simulation game of an election, but they had all kinds of simulated games. DEC and Hewlett-Packard started making major marketing efforts to sell computers to schools. And we sponsored contests for kids to send in games. And they led to all kinds of things. This was the one that this was produced by People's Computer Company, What to Do After You Hit Return. And this was basically games that had been submitted to Hewlett-Packard. and Bob Albright put this book together. And then there was another guy that published a book called Basic Computer Games, and I didn't even bring one. Well, anyway, you know about that one. And then what happened? Well, Nolan Bushnell came along, and he really liked Spacewar, and he rewrote it. He rewrote it as a coin-op game, and this is the coin-op game called Computer Space. Was marketed by, anybody remember? Nutting Associates. Unfortunately, like Spacewar, it was just too complicated for the average player. They produced 1,500 of the games, put them in bars and taverns and so on, and it was a colossal failure. However, Nolan was not to be discouraged, and a year later came out with Pong. And that one really, really took off. That was basically the basis and the foundation of Atari Corporation. Now, the same year, actually a little later that year, late 71, early 72, the two guys, Willie Crowther and Don Woods, they wrote a game for the PDP-10, DEC PDP-10 time-sharing system, which they simply called Adventure. And it was the first in the interactive role-playing fantasy games. And people just used vast amounts of computer time playing Adventure. I don't know if any of you have played Adventure, but my golly. That was, well, Scott Adams is speaking tomorrow. Huh? Oh, okay, there he is, okay. There's Mr. Adventure, and he will tell you far more about adventure games and the history of, I don't know what you're talking about. In any event, Adventure, just unbelievable, those game systems. I left DEC at that time, and I should also mention another significant publication of the same period was one that it's hard to know what the title is, but it says on the front, Dream Machines. Or is this the front? No, maybe this is the front. Computer Lib. But this is by Ted Nelson, and this is Dave All. Best wishes, Ted Nelson. In any event, lots was taking place at this point in time. You had People's Computer Company. They started this newsletter, which, well, I showed you after you hit return, but they started tabloid. That was the West Coast approach. The East Coast approach was a real magazine, which I started publishing, called Creative Computing. And we basically started publishing a magazine, and for the first time had program listings in the magazine that you could type in. At one point, where we published one program called, well, it was called Spacewar, but it was not Spacewar. It was actually Star Trek. And we couldn't use the name initially, Star Trek, but finally I made friends with Gene Roddenberry, and he said, sure, go ahead and use it, and, you know, Paramount can get their money elsewhere. But in any event, we published this game, and it ran 8 pages of tiny reduced type. I'm not even talking, you know, 12 point, 10 point. It was like 8-point type in the magazine. And then people started calling us up or sending us letters. I typed the whole thing in, and it doesn't work. Well, Betsy will tell you, we got a couple of full-time people just to answer all of the inquiries about I typed in your program and it doesn't work. And so we sort of started a policy of saying, okay, the program as it appeared in the magazine was correct. There were 160,000 characters to type in. Do you think you could have typed one of them wrong? Or in any event. But the point is that we tried to encourage people to learn debugging. And that was sort of important because what happened toward the beginning there of creative computing, well, the very beginning was we started publishing in 1974. The Altair came out in 75, and Bill Gates wrote a BASIC for it, which was based on a PDP-11 BASIC at Digital Equipment. See, we're all tying together in these things. But what happened then was, a couple of years later, Apple comes out with their computer. They use a different BASIC. Commodore comes out with theirs. They use another different BASIC. Of course, Radio Shack had to use a totally different BASIC. And so you had all of these. So what we did is we said, okay, we're adopting a policy that all of the games, programs in creative computing will be in standard Microsoft BASIC, whatever standard Microsoft BASIC was, but anyway. And if you have a PET or TRS-80 or an Apple, it's up to you to learn the differences. And by doing that, you will really learn something more than just typing in a game and playing it. So that was one thing that we encouraged people to do there. The kit era, as I say, the Altairs and stuff, that only lasted a couple of years, and then all of a sudden we got into assembled computers. So what happened with games at that point? Well, everybody and their uncle can start marketing a game on a cassette. How much did a tape cassette cost? Very little. And I mean, we had, in creative computing, we had these little 1-inch ads from all kinds of individuals, selling the most wonderful version of whatever it was. And unfortunately, the bubble, I won't say it burst totally, but it kind of did come to a point around 1983, I'd say, where there were just too many small companies, too many Me Too games, one trying to be a little bit better than the other ones. And actually, if you'll remember back to those days, well, most of you are perhaps too young to remember, but there was a kind of a backlash against arcades. And people were, trying to discourage their kids from going to arcades. So anyway, there was a little problem then. I will tell you one interesting story about that, and then we'll close. At the time, the various magazines in the industry, Compute, Byte, Interface Age, and so on, big publishers were taking an interest in this computer industry. And, when I started out, I had 600 subscribers. Well, by 1982 or 83, we had about 500,000 subscribers. So this all of a sudden looked interesting to other companies. Well, Byte was the first one to sell out. They sold to McGraw-Hill, and several other companies sold to Hearst, to some of the big publishers. And all of a sudden, I found that we had spending about $100,000 a year on circulation promotion, get new subscribers to come in. Byte magazine was through McGraw-Hill, spending $1 million a year. I couldn't compete with that. So I kind of was forced to say, okay, do I just trickle along as a small magazine? Well, 500,000 isn't so small, but you know, and try to in some way make peace with these big publishers or sell out. So I sold to Ziff Davis. Now, what Ziff Davis was doing at the time is they were selling off all of their other special interest magazines. They had a lot of magazines like boating and yachting and popular photography and so on. They had a stable of about 40 magazines. They big presence in the travel field. They sold all of it, and they bought computer magazines. They bought Creative Computing. We at the time, we actually had 5 magazines. We had Sync for the Sinclair computer. We had some others. And they bought PC Magazine. They bought PC Magazine, and what happened? The whole staff walked off, and they said, hey, there's a really good editor at Creative Computing. She's doing a terrific job. Here she is, Betsy Staples. You're going out to the West Coast and edit PC Magazine, which is what happened there. But the other thing that they did is a well-known named Frost and Sullivan to do a study on what the future of this whole magazine industry and everything is. And what they came up with were several conclusions. I know what they are. The first one was that at this point, this is 1983, home computer penetration, or homes with a personal computer of some sort, was about 5%. Their conclusion was not we have reached the peak. 5% is it. The second thing is we were just beginning, and creative computing was really at the forefront of this, covering things like CompuServe and bulletin board systems, and you know, online, you take a telephone, you plug it into or whack it into a modem, and we were starting covering this and said, this is big, and we even started a column. What was the name of that? Anyway, don't remember. But anyway, we started a column just to focus on this, and this is an anticipation of the internet. We didn't know what the internet was coming along then. Unfortunately, Al Gore hadn't told us. But in any event, they concluded, Frost and Sullivan, that this bulletin board, electronic communication, and everything was basically like CB radio. The flash in the pan was going to die out in a year or two. So that's what they said was going to happen to the internet. The other thing they said was all these computer manufacturers, you know, PET and Atari and Commodore PET, they're not going anywhere. There's only going to be 2 survivors, and in that they were pretty much right. IBM and Apple was going to be the future. So what Ziff Davis did is they basically killed all of the magazines that were covering any other computer other than IBM and Apple, and they killed magazines that were covering what became the internet. So anyway, creative computing was killed, that whole thing. And we had fun. Betsy and I left, and within 6 months we had a contract from Atari Corporation to publish Atari Explorer magazine, which is their computing, the computer division magazine. And then anyway, but don't want to bore you with that stuff. Kind of interesting, though, when you think of mistakes like that. Ziff Davis, if they had kept creative computing going, focusing on basically the internet and computer gaming, they would have owned that market, absolutely owned the market. But okay, their decision. And here I stand making 30-year hindsight observations, which is 2020, you know? But anyway. Okay, I was told I should leave a little time for questions. This is it.
Yeah, I had your book in the 80s, and I used that to learn BASIC and programming and things like that. And then, you know, that disappeared. But I ended up buying it, you know, from eBay a couple years ago. Just I wanted to relive through, you know, what I was thinking way back then. My first thought was, have you ever thought about really, you know, putting out a new edition and maybe doing it in Python? You know, something that's. Are you?
You're talking about a reprint or a brand new?
A new edition, but just do it. I mean, like my kids, they're learning Python in schools, and that's something that's accessible to them.
Well, you know, it's interesting, and not to become philosophical, but print media, for the most part, is dead or close to it. People today are looking online for pretty much everything, and that's especially true in the computer field. But I don't. Book and magazine sales in special interest areas, some are maintaining a presence, but for the most part, Now, there have been some people that have approached me and said, hey, we'd like to reprint such and such a book. And my policy has been, right from my earliest writings back in the 60s, that everything I have is for public consumption, public domain. I'm not asking for royalties or anything. If you want to reprint, and somebody just reprinted the Colossal Computer cartoon book, fine, okay, go for it. And there have been several others that have been reprinted that I'm happy to see it happen. By the way, to continue or a little digression from your question, people have also asked, can I translate the games from the 4 games book? There would be basic computer game, more basic computer games, and anyway, can I translate them into another language, Perl or Interactive 4, whatever? Again, I've said yes, and if you go on the internet, you'll find the original games book in probably at least 12 different languages. Most of the programs, not all of them, but most of them in lots of different languages. Oh. Anybody else?
Not a question, but a comment that I made to you privately, but I think should be said here as one of the real pioneer publishers. I mean, the magazines were mostly, you know, technical. I mean, different aspects of technical, from kilobaud and byte and whatnot, but I think creative computing was its name. It was creative. It had artwork. It had music. It had puzzles. It had humor. I think I remember a satirical piece about the first computer murder, where people were arguing about what was better, a TI calculator or an HP, and some guy supposedly threw his calculator at another guy, hit him in the temple and killed him. I mean, but it was creative computing, really wanted to see computers everywhere in every aspect of life, and not just for the techie. I mean, yes, there were games, yes, there were reviews, yes, there were, you know, build your own joystick articles, but it was more comprehensive and had more information for more people, I think, than any other magazine, and you deserve to be congratulated for that.
Well, very, very much appreciate those comments. We did, and my personal interests are pretty broad, as anybody reading creative computing would know. And we did attempt to make it understandable to kind of all comers and not too technical. You know, when Byte started up, there was a temptation to, you know, go. They wanted to reprint some of our materials, the software programs, and I did not reprint anything from Byte. We did actually publish the best of Byte as Creative Computing Press, but we shied away from that. And as a result, had a lot of fun. I don't know how many of you here remember the first Philadelphia Computer Music Festival. But that was something that we put together by people that had developed really early. I mean, I'm talking 1976, 77. So they were running on, not on Apple or anything else. These are S100 simulations of music. And it was an interesting time. We put out a vinyl record of the Computer Music Festival. I still have CDs that I'm gradually getting rid of, but have been trickling out. But anyway, yeah, computers are fun. That's as far as I'm concerned, and that was part of our mantra.
Person asked, did Plateau have much influence on the games?
Get that one.
The Plato system. That was Michigan? Minnesota?
Someone online's asking, did the Plato system have any influence?
Pardon me?
Plato, P-L-A-T-O.
Oh, Plato.
Plato.
Well, oh God, that's a 4-hour talk by itself. Plato, well, it was a project at the University of Illinois boy, it was kind of a branch of computer-assisted instruction, and they developed a language kind of that had some graphical elements in it. I don't know where to start and end on Plato, frankly. I really think that's probably a subject for another, another speaker.
There's a book on Amazon.
Pardon me?
There's a good book on Amazon.
I'm sure there was. But yeah, and there were a lot of projects at the time. Plato was a late 60s, 70s project. You had MIT with their language Logo. And then there were several other similar things. One was out at the West Coast in Stanford. People basically were trying to combine graphics and text and audio and and it went in a lot of different directions, and everybody thought theirs was going to be the one. But nothing really popped up to the top to take over that whole thing.
Earlier, you mentioned kind of the arrival of the different versions of BASIC causing an explosion in the home game programmer. But as we get towards the 90s, computers get a little bit more standardized, and BASIC kind of goes in the background, right? It's not the first thing you see when you power on the computer. How does that impact, the home gaming programming?
So,
as towards the 90s, computers are more standardized, but you don't get dropped into BASIC right away. How does that impact, the home game programmer situation?
well, okay, the different versions of BASIC. You'll never get an agreement on which was the definitive one with all of the bells and whistles. At Digital Equipment, I had a little issue at the beginning in the late 60s and early 70s, and that is that Digital had developed their own language called Focal. And Focal was an interactive language, very much like BASIC, same type of things. And actually, it was somewhat more efficient for a couple of reasons. Number one was that the most popular and widely sold computer by Digital was the PDP-8. It was a 12-bit computer, which is really odd, but it only had essentially one word per 12 bits. When you went to the 16-bit, you had 2 words or 2 characters in the 16 bits. So Digital had to be somewhat more efficient with their language. So Focal was a really terrific language. Problem was that Ken Olsen, the president and the CEO of DEC, did not want to license it, and did not want anybody else to use Focal. Whereas BASIC was developed at Dartmouth and basically got into the public domain practically, and they encouraged everybody to use it. So Hewlett-Packard, who was our direct competitor, I was in the educational group at Digital, I headed up that group, and Mike Hewlett-Packard, they owned the West Coast as far as computer schools. We owned the East Coast. The central part of the country was a big battleground. When Hewlett-Packard won the Minnesota Educational Computer Consortium, which was huge at that time, we realized at DEC we had to offer BASIC. Focal wasn't going to make it in the long run. And at that point, I had, in the education group, 5 different computers. We had a time-shared 8. That was the biggest one. We had a little 4K computer. I'm talking about 4,000 words of memory. That was it. That was the most popular one in schools because it cost $6,500. $5,000 for the computer and $1,500 for the ASR-33. Then we had a multi-user, semi-time sharing, but more of a multi-user machine with 8K of memory. And then we had to offer, because schools, to really teach data processing, had to have card input, punch card input. So we had to offer a card version. I had to go to outside contractors because Ken Olsen would not allow BASIC to be developed in-house at DEC. I had to go to 4 outside contractors to contract for BASIC. Do you think all those BASICs were the same? No way! The 4K BASIC, basically, well, the BASIC took 3.5K, and that gave the user 500 words to write your program. So basic commands had to be all collapsed to 1 character. No print, no go-tos or anything. It was a G, it was a P, it was 1 character. The multi-user BASIC wasn't much better, but different. Then of course, the punch card BASIC, my gosh, that was just absurd. But we had to offer it because schools, if they're going to teach computers, all computers have punch cards, or so some schools believed. And then time-shared 8 BASIC was, again, a different animal altogether. So merge these things together. And then finally, Ken Olsen came to his senses with the PDP-11 group, and he allowed BASIC to be developed in-house. And that led to a BASIC called Resource Sharing Time Sharing BASIC, RISTIS BASIC. And that is the BASIC the basis, all right, getting these words confused, basis of Microsoft BASIC. That's what Bill Gates took on the PDP-10, and where did the PDP-10 come into this? Well, DEC had 6 different computers. They all spoke a different BASIC. And this resource sharing, time sharing BASIC was probably the best one because it was the latest and it was for the PDP-11. Well, then the PDP-10 people decided, well, we have to have that too, but ours has to be a little bit better because we have a big, big computer. Ours is a mainframe, not one of these stupid little minis. And so, try to get agreement even in the same company. You can't do it. And if you're trying to get agreement between universities and the Atomic Energy Commission and the military and everybody that's involved in computing, never going to happen. Never going to happen. And I can say Ristus 11 BASIC is best BASIC that ever happened. And somebody else will say, oh, but that's Hewlett-Packard BASIC. Look at what it can do. Okay. No solution here. Hey, I think we've run out of time, folks. Sorry, but anybody wants to? Thank you.